We are going to be learning how to draw Lewis structures for simple covalent molecules. First one we're going to do is for CH3Cl. First step is to figure out which atom should be the central atom in our drawing. Central atom is typically the first atom shown in the formula. May also be the atom that there's only one of. So carbon would probably be the best choice for this molecule since it's written first and there's only one carbon. Hydrogen will never ever be the central atom, so that's something to keep in mind. The next step is to add up the total number of valence electrons in the molecule, and to do that you're going to locate each atom in the periodic table, and based on the atom's position in the periodic table you'll know the number of valence electrons that that atom contributes to the molecule. First carbon is in group 4A. So anything in group 4A has 4 valence electrons. Basically, if you look at the number in front of the A, that's going to be the same as the number of valence electrons. Hydrogen is in group 1A, so it will have 1 valence electron per hydrogen atom. However, there is a 3 as a subscript on hydrogen, which means that there's a total of 3 hydrogen atoms. So what we're going to do is multiply that 1 valence electron times 3, because there's 1 electron times 3 hydrogen atoms. Lastly, we've got the chlorine atom. That's in group 7A. Group 7A has 7 valence electrons. So we add up 4 plus 3 plus 7, and we get 14 electrons. So when we make our Lewis structure diagram, our diagram in the end should show 14 electrons, no more, no less. Next, we're going to set up our drawing by putting the central atom down first, and then we're going to attach each of the other atoms or terminal atoms to the central atom using single bonds. A single bond can be shown by just drawing a dash, and each dash represents the 2 electrons that are shared between those 2 atoms. It doesn't matter what side you start on, it doesn't matter what side you put the 3 hydrogens on and the 1 chlorine, as long as they're all attached to carbon, the central atom. Next, we take a look at how many electrons we've shown so far, and as of right now we've got a total of 8 electrons shown in our drawing. So we've got 2 here, 2 here, 2 here, and 2 here. So that means that we've got 8 electrons shown total. We're allowed to show 14, so we have 6 more to draw onto our diagram. Now the objective is for each atom to get a complete octet of electrons in the drawing. The only exception to that will be hydrogen, which only needs 2 total valence electrons to have a complete valence shell of electrons. So basically, once each hydrogen has its single bond, it does not require any additional electrons to satisfy its valence shell. The only atom at this point in the diagram that does not have 8 valence electrons is the chlorine, and so that's where we can put the remaining 6 electrons. Chlorine already has these 2 here that it's sharing with carbon, and if it gets an extra 2, 4, 6, that makes a total of 8 valence electrons. Each hydrogen already has its 2 valence electrons that they're sharing with carbon, and carbon also has a total of 8 valence electrons from its 3 bonds with hydrogen and its 1 bond with chlorine. If I go through and count up the total number of electrons in my drawing, I can see that I've got 2, 4, 6, 8, 10, 12, 14 electrons total shown. So my diagram is complete.